Okay, let's have a look at what's next here. Let's open up the calculus. We need a left and right sum. Okay. Let's see. Um, left. That one had a left in it. Did I have a left and a right one? This one had a left and a right in it, so I could reuse that. Okay. Only 10 though. Okay, so that's 10. And then it's from 0 to 1 t squared. And then uh, a6 plus 1? Okay. It's just a6 squared times the delta. Just delete all of these. Okay. Let's see. There's left, there's right. And what is it looking for? Compute the left and right Riemann sums and their average for t squared over 0, 1. Okay. Um, it's not super accurate, is it? Accurate to 2, it would seem. 2 places only. Now, it's not too bad. Now we have to do the same thing for 137. Yeah. Okay, what's different about this one? It's 4 minus t squared, and it's 1, 2. 4 minus t squared. And should be, what is it now? 1 to 2, 4 minus t squared, 1.66. It doesn't look right. Compute the left and right Riemann sums and their average for 4 minus t squared over 1 to 2. Oh, I still have a square inside. Um, 0 point, that's still off. 4 minus t squared, 4 minus a6. And is it 10? Yeah. And it's 1.66 apparently. That's not quite what I'm getting though. Oh, these were calculating averages previously. Okay, so actually, what was the average 1 previously? Is that why this? Right, 1.66. Okay, so now this time 1.66, it's right to two places again. 2 places accurate. Okay, let's check the answer for these. One was one like 138 or something, wasn't it? 137. 2 decimal places. Okay. Let's look back at the questions. Okay, so 138. Okay, let's have a look at these ones now. Let's see. If 1 to 5 is that, it's the same. It's the same. Okay. Estimate that using the left and right endpoint sums, each with a single rectangle. How does the average of these left and right endpoint sums compare with the actual value? Okay, well then, the left end and right endpoint sums, each with a single rectangle. How does the average of these left and right compare with the actual value? The actual value is just going to be a half. The left one would be 0. The right would be 1 times 1, which is 1. The average is a half, which is 100% spot on. Estimate this by comparison with the area of the single rectangle with height equal to the value of t at the midpoint. How does this midpoint estimate compare with the actual value? Okay, well, just using the midpoint rectangle, the estimate would be so just half as the height and the base is 1, so the estimate would be half. The actual the actual is also a half, so that's again 100% spot on. So let's have a look here at the answers. Let me just copy these ones over. Okay. 139. Yep. Okay. 139. So I guess this one's right. Okay. From the graph, explain why that's equal to 0. Well, it's because the area above is equal to the area below. That's the reason why. Explain why, in general, this equals 0 for any value of a. That's because the period is 1. So when you integrate over 1 period, you'll always have the same above as below. So that's fair enough. I'm sure that's the answer at the back. The graph, oh, okay, B part. For any value of a, the graph between is a shift of the graph over 0, 1, so the net area above and below the axis do not change. Yep, what I said, but more elegantly. If f is a 1 period, odd, and integral, is it always true that that equals 0? Okay, so 0 to 1, that's the period. It's odd, so let's just try and draw this back to, just turn that off. Okay, so it's odd, so that means it has to pass through the origin. And the period, it has to get back to 0 after 1. So at 1, it has to be back. Okay. If it's one period, odd, and integral over 0 to integrable over 0 to 1, is it always true that it, I think that's a no. And maybe the easiest one to see would be like, if that's 0 and that's 1. Oh, but then that's not, but then it's not, the period's not, is period 0 and 1 then? Oh, okay, it's a bit harder than I thought. You could, you could, if it's periodic, then it shouldn't matter if we shift it. So, and it has to be odd. So it goes up here, it goes down here. So, now I think the answer is yes, actually. And if this goes down, then this has to go up. So, yeah, I think it's a yes. If f is one periodic and the 0 to 1 is a, is it necessarily true that that is a as well? Well, assuming, yeah, I think all you've done is shifted it by a. So I'm going to say yes for both of these, I think. Well, the 143 is yes, for sure. Okay. Okay. Is that exercise finally finished? I think so. I think so. This looks much better, this next exercise. I'm looking forward to it. Okay, so up to 143 complete.